Okay, folks, let's look at this question involving factorizing a harder quadratic. So factorizing a non-monic quadratic where the coefficient of x squared is not equal to 1. And also part B, solving a quadratic inequality in total worth 4 marks. Okay, from the November 2023 paper 1 higher tier. So 17A. Okay, and it's a calc paper, okay? Us to factorize 6x squared minus 5x minus 14. Now, there are many different methods here to actually work this. I'm going to go about here using the AC method. Okay, so I'm going to multiply 6 by minus 4. That'll give me minus 24. So I'm looking for factors of negative 24. Okay, so yeah, and obviously add to make minus 5. Okay, negative 5. So factors of minus 24, guys, 24 will be 1 and 24, or 1 and minus 24. Okay, 2 and 12, 3 and 8, 4 and 6. Okay, and then obviously we're now going to start putting our signs in. So we want to make positive 5x. Well, that would be minus 8 plus 3. So I can rewrite the middle term as 6x squared minus 3x, sorry, plus 3x, okay, minus 8x minus 4. So this is called splitting the middle term method, okay, minus 4. I'm now going to factorize each component separately, okay, so factors of 6x squared and 3x, that will be 3x, in brackets, 3x times what makes 6x squared, or 3x times 2x makes 6x squared, and 3x times what makes plus 3x, that'll be plus 1, okay, and then I'm going to have minus, okay, the highest common factor of 8x and 4 is going to be 4, okay, 4 lots of 2x makes 8x, and 4 lots of positive 1, or minus 4 lots, positive 1, makes minus 4 or negative 4. I can see now that I've got a common factor of 2x plus 1. So my answer is going to read 3x minus 4, okay, multiplied by 2x plus 1, okay? Because I can factor out 2x plus 1 on the last line of my working and get 2x plus 1 and then open bracket 3x minus 4. So the final answer reads that. Okay, so that's our answer for part A. What about part B, guys? Hence or otherwise, solve the quadratic inequality 6x squared minus 5x minus 4 is less than 0. So, using our answer from part A, okay, this is the factorized version. So 3x plus 4, and then 2x plus 1, okay, has to be strictly less than 0, okay? So we want to now find the x-intercepts of this quadratic. So we're going to set each bracket equal to 0 and then solve it. So either 3x plus 4 equals 0 or 2x plus 1 equals 0. So when I solve the first bracket, okay, x equals 4/3 or 4 over 3. Okay, so we set 3x minus 4 equals 0. Okay, add 4 and then divide by 3. Set the second bracket equal to 0. Okay, when we do that, we get x is equal to minus a half or negative a half. Okay, these are going to be our x-intercepts of our quadratic. Okay, so our x-intercepts, okay, is going to be minus a half and 3 over 4. Okay, there we go. That's a rough sketch. So we got negative a half or minus a half. Then we got 4/3 or plus 4/3. Okay. So when is this quadratic, okay, less than 0, i.e. when is it below the x-axis? Well, it's below it in this region or this interval here. Okay, so it's below the x-axis between minus a half and 3/4. Okay, and that, guys, is the solution to my quadratic inequality, okay, yeah, for GCSE 9 to 1 maths. Okay, part B is definitely grade 9 materials, grade 8, grade 9, and part A, I would say probably, yeah, is grade 7, grade 8 for factorizing harder quadratics where the coefficient of x squared is not equal to 1. Okay, so I did that, yeah, using the split in the middle term method or the AC method. So multiply the coefficient of x squared by the constant term at the end and then work out the factors of this new number. Of course, you can do it by trial and error. That also works. It's a bit more time consuming, but this is a bit of, yeah, of like a more of a formal method that formalizes how we factorize any quadratic where the coefficient is not equal to 1. If it's equal to 1, obviously a trial and error, yeah, is obviously your best method, yeah, because obviously eliminates, yeah, like limited, yeah, possibilities. But because 6 is not a prime number, I could have had 6x and x or 3x and 2x, and it would have taken me quite a while to have exhausted all the possible, yeah, lists for the factors of 4, 1 and 4, 2 and 2. So it's not a lot of factors, but it would have still taken me, yeah, quite a bit of time. But you can do it, yeah, with the trial and error method, okay? In fact, with my students, yeah, I do it, yeah, trial and error. But because I'm making like a video here, I'm trying to obviously formalize it. But yeah, this is factorizing, yeah, a non-monic quadratic where the coefficient of x squared is not equal to 1. It's actually greater than 1. Okay, so factorizing harder quadratics. Okay, and then part B was solving a quadratic inequality. Again, that is grade 9 material. Okay, so yeah, make sure, yeah, that you're happy with how to, yeah, solve quadratic inequalities. Okay, the key is always to sketch the quadratic or sketch the curve. If it's less than 0, then it's where it's below the x-axis. If it's greater than 0, then it's when it's above the x-axis. Okay, so as a rule of thumb, okay, it's usually a double inequality when it's less than or less than or equal to, and then it's separate inequalities when it's strictly greater than 0 or greater than or equal to 0. Okay, so yeah, that's how we solve a quadratic inequality and also how we factorize a quadratic expression. Okay, thank you very much, guys.